Hello everybody, so welcome to our talk. This is about Java and .NET and using them together in one to solve problems that you have in your organizations. So let us introduce ourselves. So my name is Ben Wilcock. I'm product manager for Spring at Pivotal, and this is my good friend and colleague David. David, do you want to introduce yourself?
I'm the .NET Product Marketing Manager at Pivotal, alongside Ben.
So what we're here to talk to you about today is this. So we have a story to tell, and it's all about, it's loosely based on a real-life event. It's not actually real life, it's more like Fargo, where it's sort of been made up, really. But we do a lot of work out in the field with clients of Pivotal, and this particular talk is based on some learnings that we had around working with one particular client. So that's what we're going to talk to you about today. It's about an acquisition and how that acquisition was handled, how teams working on different platforms were brought together onto a single platform, and how teams using different languages were able to communicate with each other and get their software to communicate with each other as well. So it's a story about an acquisition. It's also a story about a modernization, because it's obviously never enough for the boss just to acquire some stuff. You've also got to do some modernization and some other things at the same time, so that's exactly what we did. And then if there's some time at the end, we'll talk a little bit about the future and other things that we can do with this particular architecture now that we've built it. So that's what we want to try and talk about a little bit today.
Now, before we get started, by a show of hands, how many Java developers do we have? Okay, .NET developers? Okay, can you guys go Java, you all just right in the back there, just be fine for you right back there.
That's a very surprising split, because it would seem very even, actually, and that's,
yeah, that was.
That's great. So, so hopefully what we'll talk about today will be of use to you, because obviously I'm a Java person. I've worked a lot with Java and not really with .NET very much at all. But David, your
when I came to Pivotal, they taught me how to spell Java. But until then, I'd C# all the way.
So I'm going to tell you a little bit of backstory. As I said, this was based on a real-life event. So this was a story about a banking customer of ours who'd been established for many years and had a lot of legacy. Most of that legacy was with Microsoft platforms. They've got a lot of Microsoft platforms in that particular bank. But they also wanted to capture some more market share, and in order to capture that market share, they wanted to offer new products. One of those products was a loan-based application, one where you could get loans very quickly. And they'd been out to the marketplace and they'd identified a particular vendor not too far away from where they were that had some technologies that they felt that they could use in this particular lending situation. One where they could analyze loans and say, okay, that's a good loan or that's a bad loan. So what they wanted to do was capitalize on that, and they decided to go through an acquisition and actually just acquire the company and bring that technology in-house. But as you can see from this diagram, the bank was very used to working in Microsoft and Microsoft technologies. The company that they were acquiring were all Java and all based on Java Spring and that sort of thing. So as part of the merger, they wanted to do two things, really. They wanted to, first of all, build a platform that everybody could use, whether they were Java or .NET. But then also bring those technologies together, get them to communicate with each other well, and then offer, based on that, some new technologies out to the marketplace to let them sell more loans and grow faster. So if I talk to you a tiny bit, no, you're going to talk next, aren't you? You're going to talk about what things look like before the acquisition.
Right.
Okay.
Yeah. So before the acquisition, first the call it the main branch of the business they were Microsoft based. They were actually relatively modern on .NET Core, using microservice architecture, things like that, good practices. Although they mix in a little bit of monolith flavor in there as well. given that the configurations, things like connection strings, business rules, things like that, were built into the application. They were compiled with the application, right? And that's not an ideal place for those kinds of settings to be. The application is running on Windows. It's written in .NET Core. Its data store is a SQL Server database, pretty typical, I think, application for most of us. Also, the IP and DNS, again, was inside the application, hard-coded in the application. Not an ideal place for those kinds of things as we try to move between different environments. It is a RESTful API, has 2 endpoints on it. Pretty straightforward there for .NET Core.
And it's fair to point out as well that the applications that we've looked at today, that we're going to look at today, they're just the tip of the iceberg, really. There's a lot of other things going on inside the bank. Sure. So these are just this sort of...
This is our loans hello world today.
Right.
And then the Java side, also a RESTful API. Loan Checker, as we affectionately call it. It's a Spring Boot application. It's got a bundled config, so not unlike the .NET side where we've got some things hard-coded or living within the application that are not ideal. It is a RESTful endpoint for JSON. It has some fixed IP addresses in there. And now notice this has no backing data store on it, right? Because this app is simply processing information and feeding you an answer back. That's all it's meant to do.
And one thing of note, I think, on both of these slides was you probably noticed that this particular app is running on Ubuntu in a data center in Paris. The other app is working on Windows in a data center in Berlin. So very traditional kind of architectural choices been made there about where the infrastructure is and where it runs, right?
Good. So first, we have these 2 applications. We're going to bring them together. So before we get to writing any code or choosing any sort of architectural design, we need to pick the right platform for them to go on, because that is going to affect our architecture in a big way, right? So we're going to decide the platform of choice based on business goals, right? We're not going to just put technicals down and say, here's what would be nice for the developers, because that's not going to help the business at all. We're going to say, what are our business goals? What do we want to accomplish by bringing these 2 applications together? That's what's going to drive our decisions for the platform. So first, we want to keep the existing languages, right? We're not trying to change anyone over. It's maybe a Microsoft company, a lot of .NET within the company. We're not going to merge a Java app in and then rewrite it into .NET. That's not going to help anybody out. They merged because it's a good app and it works the way it is. Let's keep them separate, right? So their pipelines, their IDEs, their tooling and things like that stay separate. Keep them the way they are. We're going to stay on one cloud platform. Maybe a little bit of a coincidence. We're going to go to Azure, maybe. But the key is we need to be able to work within multi-clouds, maybe even on-prem, right, for our platform. Because maybe we need to keep our QA, our developer environments on-prem in some infrastructure there, and then our pre-production, load testing, and production need to be up in the public cloud, maybe even multiple public clouds, right? These kinds of restrictions. We want one platform to support both Windows and .NET, and what that means for operating system is we want our hosts to be Java on Linux, and we need Ubuntu on Linux, and we need Windows servers running up here, right? But we don't want snowflakes here, right? We don't want to have to bring in a Linux guru that knows everything about managing Linux and running it at production, and then creates a bunch of snowflakes of Windows servers because they've just never seen them before. Our platform needs to give one interface to manage everything. It's the same environment, right? And then finally, we need a marketplace of self-service offerings where we are going to go 12 factor. We want to meet as many 12 as the factors as we can. So we want to offer our developers a marketplace of services. They bind their application to the services and consume them. They don't deal with IP addresses, connection strings, things like that. They don't know anything about it. They don't see that stuff. Just give me a database and let me go.
So this is like a complete sea change in the way that this particular organization views how they write software. And it's starting with a platform and it's putting these constraints in place and saying, okay, we like the idea of a platform, but we'd like some things to remain the same, like our languages. But at the same time, we want a lot of things to change. Like we want to be able to commission our own databases as a developer without raising a ticket and all that sort of stuff, right?
Exactly, yes. So the winner is Pivotal Application Services. Yes? Good? Best platform out? Thank you, thank you, thank you, Dormain. Pivotal Application Services is the winner, right? You may know Pivotal Application Services as Cloud Foundry or Pivotal Cloud Foundry. We're saying the same thing between all these. Pivotal Application Service runs Windows and Linux, both. It is a unified experience for devs, right? So that means I can show up with my, in .NET Core, I can show up with my EXE and all my dependencies. In Java, I can show up with my jar. I put the same manifest, same looking manifest on either application, and I issue the command CF push, right? It's the same experience between the two runtimes. The operators of the platform have no idea what kinds of apps are running on them. They shouldn't care. They should just make sure the platform is running well, everything's right between all the different hosts. We can run Pivotal Application Services on any cloud. In this instance, we're choosing Azure to run it on. We can run it on other public clouds. We can run it on-prem. It's the same experience. It's the same ops manager. It's the same apps manager. It's the same CF push command, no matter where we're running on any cloud. You know, the developers almost don't know where they're running. Developers don't have any clue which cloud they're actually using. Multi-tenant, meaning we want to get the most out of all our VMs, right? One VM is going to be running, think of it as an application server. One VM is going to be running many applications, many containers on it in a safe, isolated way. We want to pack those VMs as full as possible of containers to get the most out of our hourly rates for our VMs. And then PAS has a self-service marketplace, as we're going to see in a second, where a developer simply goes in and says, here's all the services that have been installed on the platform. I want a database, I want a cache, whatever I need, bind it to their application, they're handed all the connections, and go for it. So a little bit more about the marketplace. Specifically, we're looking at Spring Cloud Services, right? So on the Pivotal Application Services platform, an operator can install Spring Cloud Services. We call it a tile. When they install Spring Cloud Services, you get a service registry, you get config server, and you get a circuit breaker dashboard with that. Hystrix is what you might know that as, right? Install the tile. We're going to configure a little bit about the networking and all that. A developer is going to come into the marketplace and say, I want a registry server. Give it to me. Bind it to my app. I'm done. There it is. We're also going to install, and Ben's going to get into those in just a second, a little bit more about Spring Cloud Services. We're also going to install the Azure Service Broker. Now this is pretty cool because so your operator of the platform can install the Azure Service Broker tile. When they do that, they're going to give it some credentials about what Azure account subscription to use and some other bits and pieces of some metadata of how to track things and all that. What that's going to do in the marketplace to the developers is expose all these services, right? The developer can then go in and say, in our case, we're going to use a SQL database. So they can choose Azure SQL and say, give that to me. The developer is never going to actually go on Azure to use any of this, although they're natively using these services, right? They're never actually going to go on Azure. The database that's named out there on Azure is some, long string, some GUID or something, right? They're never going to see that. They're never going to see the credentials for that database. They are going to interact with the database solely by software, and that's it, within their code. Migrations, all that good stuff. That's how they're going to interact with the database. They don't need to see the database. They don't care about the database. Just give me one and let me go. So take that same example with all these different services, and you're just handed a service on the platform to use.
And that's pretty exciting, isn't it? Because it gives you so many new opportunities. So
you get going so fast for having all these services, building some really, really rich applications.
But in terms of this example, why, as I said earlier, it's also an opportunity to modernize. So by bringing these two applications together, we want to get them to communicate with each other, and we also want to change small things within them that make them easier to run in the cloud. So I'm going to go into a bit of detail about two of those examples. So one of the things that we said that we wanted on our platform was Spring Cloud Services, and what Spring Cloud Services can give us is access to a config server and a service registry. Now, why do we want the config server? Well, 12-factor tells us that we don't want to contain our configuration inside the code. Code should be separated from the configuration. So the config server gives us a way to solve that problem by allowing our applications to attach to that at runtime and resolve their config. So it means that the configuration can vary between environments, and the application code never really carries that configuration with it. The only thing that it needs to know is where to resolve it from. So we'll go into some detail about how that works in a little bit later. Same story with the with the service registry, really. So when you have essentially an elastic cloud, a cloud where applications can be spun up and scaled and moved around between different locations very easily, then what do you do about when one application needs to talk to another one? How do they find each other? How do they resolve where they are at runtime, as they could be anywhere in the cloud, right? So that's something that Service Registry allows us to do. It means that we can have a dynamic address book of all those service locations, and services can register themselves at runtime so that they can say, I'm over here, I'm on this particular piece of infrastructure, and clients can go and resolve that in real time as and when they need it. So if I need to communicate with my loans checker, for example, I know exactly where to find it. I can find it through the registry. So those were just two examples of modernizations that we wanted to make to this architecture as we moved it on and merged these things together on our paths. So in terms of modernizing the architecture, what did we want to do specifically? So I've got a build here, so I'm just going to build this up. So we wanted to do three things. First of all, we wanted to move the applications onto the Cloud Foundry paths. Remember, that's all been installed on Azure, so underneath the hood, it's all consuming Azure infrastructure, but developers will communicate with it using the same developer experience. So we want to move these two applications to that path. Secondly, we want to use the config server for both the applications, so we want to tell both of them how to use it and how to resolve their configuration at runtime. And thirdly, we want to use the service registry so that as things spun up in the cloud, they're registering their location with that registry server so that clients can find them at runtime really easily. And we're going to go into a little bit of detail now about how we achieved each one of those things individually, starting with how we move applications to Azure. So moving applications to the paths. First of all, we install the paths. Pretty straightforward for most admins to do that sort of thing. It's not too difficult. And then we add the Azure Service Broker into that. And then we create our Azure database. So that's because the loan application needs a database. So we're going to create that. And then finally, we're going to push the loan application onto paths. And then we're going to do the same thing with the loan checker. So we'll show you now a little bit of detail about how that's actually achieved physically at the desktop of the developer when they're essentially changing this architecture so that it starts to look as described on the previous slide.
So first, a few commands here before we get into the actual .NET or the Java and C# and all that. So I'm going to start from the loan applications, top left box there. We're going to be using we call it the CF CLI. That's the Cloud Foundry CLI. So this is basically a CLI for interacting with your given foundation, PAS foundation. You tell it, here's the location of the foundation, here's my credentials, and then lets you begin to interact with it. So we've authenticated ourselves. We issued a CF create service. So create service is going to say, I want to create a registry server for binding. I want to create a config server for binding. those types of things. And I want to create a service broker. I want to use the Azure Service Broker and create a database binding as well. Then we're going to create or do a CF share service. So this is kind of where it starts getting cool. On the platform, you have the notion of orgs and spaces. Think of an org as a product or a development team or something like that.
Business unit. Yeah.
Business unit,
Could be anything, yeah.
Think of a space as a certain environment. So like development, QA, load testing, production, that sort of thing, right? What the platform allows us to do is, actually in the org where the .NET app was running, I did the create service command, and then I did a share service over to Ben's org, right, which would be the Java team. Now we're sharing service instances between our orgs, but we've kept a very logical definition between the two teams. So we could have different Git repos, different build pipelines, right? We're still running the same as we once were, but we're sharing things like a registry. And I did a share service of the config server as well between the two. And then finally, I pushed my application up. Ben did the same. We attached a manifest, and so the bottom box is there, the manifest. On the left is the .NET version, on the right is the Java version. Very similar between the two, right? You really don't need to have any expertise in any certain runtime to understand what's going on here. I choose the Windows stack. I choose a binary build pack. This is a Cloud Foundry thing. Here's the route that I want for my application. I set my ASP.NET Core environment to staging, because that's the first place I'm going on the platform to go onto production. And then I told it, here are the 3 services that are available for binding I want my application to use. The Java application did the same. They set their path, just a little bit different there, right? Our manifest on the .NET side was put in the same folder as where you published. And then it found everything. It found your exe, it found all your DLLs and everything. On the Java side, you're going to put it with your jar, and then it's going to do it all. So that's about the biggest difference we're going to have here between the deployments. He chose the Java build pack, chose a route for it, chose his environment, and chose to bind the config server and the discovery server, not the SQL, of course.
Yeah, so that's what's really cool about it. Our developer experience is exactly the same.
Very similar.
I type CF push, and on the Spring world, I use my, essentially I've created a jar, so I've built everything as a bootable jar.
Further along here in a little bit, we're going to get into specifics on build pipelines, and I'll show you in Azure pipelines on the .NET side how we actually built this manifest to be generated and such.
So the second thing that we wanted to achieve in that target architecture was to introduce the configuration server so that we could essentially externalize all of our configuration and no longer keep it inside our code repositories. We could have it somewhere else. So how's that achieved? Well, first of all, we externalize our configuration. So we take the stuff that's normally bundled inside the app and we put it into a separate repository. And then we can do that for both of our applications. And this is how it's done. So first of all, we need the service to be available. David talked about that a little bit already. So we CF create service, and we bind it to our application. So it's literally 2 lines of CLI code, so it's really straightforward. But you'll notice there's a JSON file, and that JSON file is telling the config server that we are creating as developers where the configuration actually lives in GitHub. So it goes out to GitHub, pulls that down, and uses that as the configuration at runtime. Then it's simply a case of creating a file. So I touch the application YAML there. I add myself a configuration that I want to externalize. In this case, it's the maximum loan amount. So the maximum amount of money that someone can borrow using this particular loan application. So I put that into my YAML, and I send that out to Git. And that's what you can see on the last slide there. So we're just committing that, and it's done.
So the thing to note there is each of our applications were in their own respective Git repos, right, out wherever we want to use them. Then this third one is holding our configurations. It's in a different place. It has its own history, right? It has its own following for everything, for how you're interacting with it. So When you tie this back to maybe RBAC and things like that, and who has access to what and who can do what, you have very, very clear lines of separation between actually sending up business logic and such versus just code and artifacts and all that.
So what does that look like in Java? Well, it's really straightforward, and there was a lot of hands up in the room. I assume there's quite a few people who have probably seen Spring already, but for those who haven't, we add a dependency to our, essentially to our manifest for the application itself. It's called a POM, so we do that. And then we must set our application name. This is important for the config server because you have to go and identify which config you're after, especially if we're sharing a config server with lots of config in it for both .NET apps and Java apps. So we say, I'm the loan checker. And then lastly there you can see there's some more configuration that we've added into Git. And finally the actual code that enables us to use that configuration is shown. So enable configuration properties is a switch on Spring to allow it to use basically automatically build an object with certain configuration within it, and then the configuration itself is built at runtime. In this case, it's a naughty list, people who we shouldn't be loaning money to because they perhaps haven't paid back, or perhaps they're a person of interest for other reasons. But in this case, we're configuring the naughty list. But that's essentially how it works.
So on the .NET side, Spring, the Java developers have the Spring framework. The .NET developers have the Steeltoe framework. They're complements to one another. So in this case, we're using Steeltoe to bring in the config server dependencies into the application and be able to create a client. We're going to set our application name. So this is an app settings JSON. You're going to set your application name. So this is one local configuration value that you're going to set, and a minor one at that I would offer. In our external Git, where our configuration is held, just as Ben did, we set our other values. In this instance, it's max loan amount, right? So we're getting into some business logic here about what the application is willing to process and not. He had a naughty list, and we had our max loan amount in there. So see where we're going with this. Now our application is being tested, artifacted, and published, and the application is just there to move things around, right, and process business rules. But what makes up the business rules is outside of the application. Very portable, right? Very cloud native in that respect. Number 4, admittedly this gets a bit involved, but what's really cool in .NET Core is when you get into configurations, when you get into the options patterns of configurations, if you've ever spent any time there looking at that, the .NET Core team has done some really, really cool things in there. And you can really manipulate environment variables around and override other things and build out an entire list, a hierarchy of values as they come into your application. But create it so you can push your application from dev, staging, pre-prod, prod, and never change a thing about any of them. It's a really great thing. So in this case, we brought in, we did the add config server. We'll bring in our middleware in our configuration services. This now made bound a class called loans configuration options to the environment variables that are brought in. So I admit this gets a bit in depth here on it, so I'm not going to go too far. But the cool thing is now we have a class of variables holding our configuration values, which means underneath something could change the value of those variables and our application doesn't care. And in this case, you could check in a different configuration to your Git repo, go to a refresh endpoint on your .NET app, and all the values refresh. So to your production apps, you can change the max loan amount to $50,000. Go to your app, hit this refresh endpoint, and it's going to take those values in now and continue on. No reason to do any sort of blue-green deployments or any sort of updates or deployments or anything like that.
So let's just talk quickly about what's actually happening as we run these things at boot time and at runtime. So as we boot, the config server is essentially added to the environment of the container that's starting, as a set of environment variables. So the details about where the config server lives is in those environment variables. The client then, as it's booting, can look for the config server, and it goes and finds the config server and asks for its configuration by name and by profile. And if you remember, that configuration server is backed out by Git. So all of the configuration that's in that server is actually in a Git repo, and that's all managed and versioned in the usual way. At runtime, that means that we can do some quite interesting things like refreshing the config live. So while an application is running, without the need to actually bring it down and start it back up again, we can hit an endpoint on there to tell it to go and refresh its config, and it'll go and get a fresh set of configuration from the Git repo. So if you've just made a change, you can hit that refresh endpoint, it'll pull it into the application live without having to restart it.
I kind of stole your thunder there, didn't I?
No, that's good, because it's worth reiterating, because it really is very different to what your normal experience is, which is to rewrite your config, rebuild your binary,
and all that.
test it in all the usual ways, then put it out to production after you've gone through 3 or 4 environments. This is much quicker and allows you to do things in a much more fluid way. So then let's talk about a service registry now. So this is another thing that we wanted to do here to modernize this application. We wanted the loan checker to go and place itself into an address book, and then for loan applications to go and find that at runtime based on its location in that address book. So how do we achieve that? Well, first of all, we register at boot time. So at boot time, the loan checker is going to say, I'm over here, I'm on this particular piece of infrastructure. That's going to go into the registry, and the loan applications are then going to use that registry at runtime to say, okay, where can I get my loans checked? Where's it going to live on the infrastructure? So what does that look like on the Java side? Again, a very familiar story from earlier. So same thing happening here. We're using a Spring Boot starter to say, okay, I'm using the service registry. Spring Boot will essentially use that at runtime and know how to behave as it boots. Second thing we've got to do is set the application name, again, because we need some key for the registry server. We've got to call it something. It's got to be a recognizable key, and that's what we're creating here by using the application name. And then lastly, we say in the loan checker, you need to use the discovery client. You need to go and register yourself at boot time as an application that lives in the registry. And then in the bottom right-hand corner there, you can actually see a screenshot from the registry itself, and this has happened after boot. So here is the loan checker. We have the status there, which is using a health endpoint to describe its status back to the service registry. But that essentially means that the application is now discoverable. And the beauty of that is now it's discoverable by .NET apps, right?
So from the .NET side, again, we're going to be going back to the Steeltoe Framework. We're going to bring in a discovery client. And this is pretty straightforward. So one of the bigger differences between the Spring Framework and .NET Core is the Spring Framework is going to add your middleware and mark it all for use automatically for you, annotations, right? In .NET Core, they went a little bit of a different route where you have to add and then use your middleware for it. So that's what we do here. We add our discovery client. We're going to feed in our configuration. The Steeltoe Framework is going to be able to look at the configuration, parse it, find all the connection values, everything that we need to be using, and establish the connection. All of it happens for you. And then we do our use for the discovery client. That's it. That's all my code for implementing and becoming, if you will, the receiving end of a discovery client. Our example here says, here's my configuration. This is a specific configuration for the loan approval service. What scheme do I want to use? What is the address of the loan checker? Notice it's a name, not a URL. And then a few paths of a health check and of actually running the check, the health check endpoint. I'm going to, again, use the options pattern in .NET Core to do this, load it into a class. Now, the interesting thing here is I'm trying to be a good cloud-native .NET steward. So we're going to use an HTTP client. We're going to implement HTTP factories, right? Because we don't want to be opening up threads every single time a request comes in. So this is a .NET Core thing, not so much of a Steeltoe thing. In the configuration services, we're going to set up an HTTP factory, and that factory is going to be associated, given a typed client, of our loan checker service. In the constructor of our loan checker service, that is where we actually bring in our config values and we set our base URI. So now we've said any calls that are made within this service are automatically going to get this base URI on it. And because we've said that we're going to use a discovery server, .NET Core and Spring config know how to talk together and say, I'm going to go find this application in the registry, I'm going to discover its real URL, and then I'm going to actually make the HTTP call to that URL in a very, very cloud-native, thread-safe, optimized way.
So let's look again quickly at what happens at boot time and what happens at runtime. And the story now is very familiar, hopefully. First of all, at boot time, again, the environment properties for where is the registry is going into the environment of the container that's starting. So the libraries that we're using then know how to use that information and go and connect to the registry. So the client looks for the registry. When I say client, I mean the application that wants to register itself in this particular context. It registers itself by application name, it registers its location, and its health is checked, because obviously we don't want stale information to stay in the registry. We want to be continually also checking the health of the things that have registered. So,
and that registry, just a quick note about that, you know, the registry is not only to discover services, but to also create high availability as well, right? Or maybe a little disaster recovery. I could have service registries spanning multiple data centers. Availability sets, whatever you'd like to do, right? My application doesn't care. Just give me the URL of where you are, what's available. The URL that's associated with the service, it could be a URL calling 3 different data centers. The app doesn't care, right, to keep things highly available. So all of that is abstracted away, and we just let the registry take care of managing the URLs of who's active and who's not.
At runtime, the client, if you like, the client that wants to talk to the loan checker, that's just talking to the registry, and it's saying, where is the loan checker right now? What is its location? So it's pulling that location information down, and it's asking for it by name, not by IP address or by GUID or anything like that. It's just straightforward. And then the client calls that application. So now these 2 applications in the past can now talk to each other. They can, your application handles essentially the loan processing, and my Java application handles whether or not it's a good idea to lend money to a particular person, right? So now they can talk to each other. They can achieve that particular process quite happily, right?
Right.
So let's talk about the finished architecture then.
Yeah. So we've been building on this a little bit. I know all of you have been very worried about how this is going to look ultimately, I can tell. The final architecture here, we've got our loans application, we have our loan checker, they're talking over REST, right? They each share a config server, they each share a registry server. We won't talk this too much to death here, I hope we've explained it well enough. The key thing is the configurations, loan threshold, naughty list, what have you, are completely held outside the platform and refreshable, right? Because an application, a cloud-native application, should not care about any of this. It's connection strings or anything like that. It should be assumed you're going to give me a good connection, I'm going to connect, I'm going to have a good schema, and I'm going to do my thing. Or you're going to give me a config server, you're going to tell me how to process the business rules, and I'm going to do those things. Right? The application is just there to actually do the processing for it.
Absolutely, and I think what's important to call out here is that the things that we wanted to change, we've successfully changed. We wanted to have config server, we wanted to have a registry because we want our microservices to behave well in the cloud. So those are the things that we wanted to do, and we achieved those really easily. The things that we didn't want to change, things like the languages that we use, the runtimes that we use, the operating system that we used, they've all stayed exactly the same as they were before, with no interruption to service and no interruption to the way that we approach our work, right?
Yep. Into the build pipelines a little bit and getting into automation. From the .NET side, our microservices are using Azure DevOps. Specifically, we're really looking at Azure pipelines here. Again, the originating company was a Microsoft company. I hope most Microsoft companies are moving to Azure DevOps, whether they're on-prem or not. And the pipelines, I'd like to think they're pretty simple, they're pretty straightforward, right? We're going to build our application, we're going to copy up our CI files, those are our manifests, right? That's on the build side. That's going to do our artifacting and all that for us. Thank you, Azure DevOps. And then on the release side, we're going to take that artifact, we're going to push it to staging, probably mixed in some testing and all that there. We're keeping a simple example here. Push it up to staging, right? So that's the introduction of Cloud Foundry to the platform of a real service registry. To that point, all the development has been done locally. So we've been doing a Docker image running a service registry, a Docker image of running a config server, that sort of thing. Now we want to introduce the real deal to the application. That's where we're going to do our smoke tests. The point of our smoke test is to prove all the services were bound correctly, we can interact with them, they're available, health checks pass, all that good stuff. And then finally, we're going to push on to production. Now, the interesting point here is, though, I'm big on pipelines, and I really enjoy working in Azure pipelines. We're going to put a check right before push to production, right? Because in a cloud-native world, we want the development team to go fast, right? We want the development team to own all of their pipelines. But there's some reality here in enterprise. Developers can't go all the way to production. So how do you find that middle ground? And one way that we try to introduce that with our customers is, let's put a check right there, right, an approval. It may be change management, it may be management, it may be business owner, what have you, right? Multiple in there. But the application team defines the pipeline because they know how the app should be deployed. But higher entities, management or change management or whoever, actually does the approval to complete a push of the pipeline. I hope that's somewhat clear about finding those bounds and respecting those different roles within the organization. In my opinion, Azure DevOps does a very good job of this, makes it very, very easy to do this. This type of pipeline could be transferred over to TFS or VSTS if you're using that kind of stuff. This is a pretty synonymous, I think, example. Java.
And it's pretty similar on the Java side as well. Mm-hmm. So we said categorically that we didn't want to change certain things about how we work, so IDEs and languages and that sort of stuff. But in future, there's no reason why we might consolidate, certainly in terms of CI and CD, onto one of these platforms. But at this point in time, the Java side is handled by concourse. So concourse gives us a really good way to describe pipelines for producing software and delivering software. And it's a very similar story to as it was on the .NET side. There are lots of things that are automated and can happen automatically, but there are also some steps in there that we have introduced some checks and balances to prevent us from over-publishing when we don't want to do that. But there's also lots of places that we could go with this in the future. We might introduce more spinnakery type stuff where actually we're taking a health check and a baseline and then working from that baseline, letting the software decide whether or not the upgrade is working, whether or not it's...
Using concourse with your configs, right? And letting some things drive there, yeah.
So yeah, that's where it currently is today. So finally, let's talk about what's next. So it was a really exciting project, this. We really enjoyed working on it, I think.
Yep.
But there's also, it's left us with an appetite to do more, and there's so much more that we could do, I think, as well.
It has, yeah. So, and in fact, Ben's going to get in just a minute into some different ways to approach the architecture. I think there are some very cool things that you can do when you use a config server and a registry server. A lot of very, very modern option doors, if you will, are open to you. when you have these types of things. But let's look at a little bit of reality as well. Now we're going to go to production. So when we go to production, two things really come to mind: high availability and scaling, right? Probably disaster recovery is in there too. Cloud Foundry is going to take care of that in a very simple way, but we won't get into that. High availability means, in terms of Cloud Foundry, we're going to be running availability zones, right? If you're familiar with other cloud platforms, they use the term availability zones. We use it on vSphere on-prem. We also use it in Azure. You may have availability sets on vSphere. Same idea, right? Different data centers, different rows in a data center, whatever is reasonable, right? We want to run multiple instances of an application at all times to make it highly available. So if we're running 3 availability zones, we're going to run a minimum of 3 instances of our application. And our platform distributed them between those different availability zones. We don't deal with any of that. That's just given to us. We're also going to attach an autoscaler to our application and put some rules in there. Again, the Pivotal Application Services platform is going to hand you all of this to do all these things: high availability and autoscaling. Autoscaling is going to look at things like your rules could be based on memory, could be based on latency, probably on latency. If my service ever goes above a certain threshold, I want you to scale by 1, and then scale by 1, and scale by 1, and so forth. And then when you fall below a threshold, retract back, right? Those are auto-scaling rules. But never go below 3, because that's always going to keep our app highly available, and we do have to put some sort of ceiling on it when we're talking about scaling rules.
Similar, in terms of the design, things that we could do with the architecture, we barely scratch the surface of all the things that we could do with Azure, for example. So by adding the Azure Service Broker and having access to all those things, really opened up the possibilities in terms of how we could re-architect this particular set of applications, this suite of applications, and use things more intelligently. So, for example, we've added the registry, and the reason that we've added the registry is so that applications can find and communicate with each other, generally over HTTP. Mm-hmm. But what if we had eventing? What if we used Azure Event Hub instead, right? So could we do things asynchronously? Could we have more resilience because things could happen offline as well as online?
Messaging.
Could we utilize that in our architecture to reduce some of the strains and some of the reasons why we need things like registries, for example? Maybe we don't want to do that. If not, maybe we should be introducing circuit breakers so that if communication breaks between these two applications because of an outage or whatever it might be, can we have some sensible defaults so that customers still get a reasonable experience? They might not be able to, get a loan, but they're not going to see an Internet Information Server, blood red screen with all that stuff, exception code dumped out all over it. The circuit breaker is going to help us by giving us some intelligent defaults and some friendlier messaging that we can do around that, so that the customer's experience isn't as interrupted as it would otherwise be. And
even because the .NET app is the, if you will, the public-facing side of the application. And it's relying on a shared config and the shared Java app. What if somebody fat-fingered something at configuration and they pushed it up and it broke things, right? We don't want to break the front end. We don't want the customer to see any issue. But the .NET team has their own pipelines and has their own configuration, so they don't have full control over what's being pushed up. So something like circuit breakers could be that catch for them to say, just in case, if something happens, gracefully show a message to the user of, sorry, you can't do that right now.
Exactly. And then finally, maybe API gateway would be quite useful as well. There are so many things that you can do in an API gateway in an architecture like this. I think it would give us some options around how we handle security, how we manage the traffic that's going through this architecture, where that traffic is going to. We can handle things like versioning and versioning over time through an API gateway as well. So these 3 things really were the top 3 on a longer list of stuff that we wanted to start to take a look at as we iterate on this and move forwards. But there's lots of things in here that we can use via services in the PCF paths. So lots of different places for us to go, I think.
Yep. And a common pattern that we would see with some customers is they want to use a public cloud, but they want to funnel the traffic back through their local networks, right? Things like that. We're going to create a data pipe between our local network and the public cloud, but that public cloud can't actually accept any public traffic. It comes through our network and then is routed up there. And so the introduction of an API gateway and things like that makes it very, very easy, very, very manageable and straightforward to implement these kinds of things, to adhere to security and business rules and that sort of thing.
So before we finish, a couple of final messages. So first of all, we really do value your feedback. So if you have the time, please follow that link and give us some.
Please.
We'd really appreciate that. It would help us to add stuff in or take stuff out and iterate on this talk as well as on the architecture, which is good. And also, we should say that the code that's behind this, today you've only really seen it in snippets because there's quite a bit of it and it's in different places. But we are going to make that available to you. It's not available right now. I think it 404s right now because it's still a private repo, but we're in the process of making it public. So if you take a photograph of that slide, the link in the bottom corner there will take you to the code, and you'll be able to see the Java code, the .NET code, and the configuration that we've used, and a few scripts to show how we've done things like setting up the config server.
The CF commands, all that stuff. We've tried to document everything along the way to show you the full process.
But that's it from us. Thank you very, very much for attending.
Thank you for your time.
If you have any questions at all, come down to the front here. We've got a couple of microphones. You can ask away. But otherwise, again, thank you very much.
Thank you.